Okay, this video is all about how you draw or represent the electric field around a point charge. So if we have a point charge, a positive point charge, and down here I'll draw a negative point charge, how do we represent the electric field around it? Well, we represent most forces with vector arrows, and it's no different here. So around a point charge, we can draw lines of force. And the way we draw them is they are evenly spread and radially spread, so spread out like around a circle, and the lines should be equal length, equally spaced, and they basically show us the direction that a small imaginary positive particle would move. If I had a really tiny positive particle and I stuck it there, then which direction would it move? Well, it would head off in that direction. Okay. We could continue to draw in lines and fill all this gap 360 degrees around. That's a bit of a waste of time. So we can just represent it with several lines. And so have a think about how you might represent the field, force field, around a negative charge. So it's roughly the same. So we have these lines radially spaced. But what we need to think about now is which direction do we put the arrowheads, or what is going on? So same thing, we get our little positive particle here. Whoop, it's bigger now. And we think, which way would that positive particle go? And the positive particle would be attracted to the negative source. So we draw the arrows pointing in. So positive charge, arrows spread out radially. Negative charge, arrows spread out radially, but they're pointing towards the negative source. What happens if we have a plate here, a metal plate here, and a metal plate here? And this plate has a positive charge, evenly spaced, and this plate has a negative charge. Now we need to represent the force, electric field of force between these two plates. And so again, we would have some evenly spaced lines. We go right to the end of the plate. And then what happens around the edges of the plate is that there is still some force, but it's a bit more spread out. Not as direct, not as strong. Which way are we going to put these arrows on? Same principle. Which way would a positive charge move? It would move away from the positive plate and it would move towards the negative plate. This is how we represent force field lines in an electric force field. Always away from the positive and towards the negative, evenly spaced because the charges would repel each other equally, and towards the negative.